Transitions Signature 7 is our newest generation of core photochromic lens. What's really different is in the photochromic technology, we've developed a group of dyes, which we call it Chromia 7, and those dyes are able to react to low levels of UV. Normally we think about photochromic lenses just facing the sun, but in real life people are wearing caps or they're facing away from the sun, you get partial shade, and we know that the property that people most want in a photochromic lens is darkness. So in Transitions Signature 7, the Chromia 7 technology is able to react to that lower level UV light and give a darker lens under most conditions.
When it comes to fade back, it returns to clarity at the same rate as Transition 6. That's a 20% increase in fade back speed.
In terms of technology, we're always pushing the innovation. We're very excited about Transition 7, about the new technology. Our commercial team felt in terms of rolling it out in Europe, we really wanted to have kind of signature venues and have signature events to showcase the new product and the new technology. Transitions, traditionally when we introduce a new technology, we believe that the new technology performance attributes are always better, that there are things that consumers value and have benefit. So we do replace our current technology. So Transition 7 will be replacing Transition 6. We staggered the rollout around the world. Europe is actually the first region in the world to launch Transition Signature 7. For most of the rest of the world, it'll be next year, 2014. So this is a photochromic molecule. This is one of a family called naphthapyrans. In fact, for Chromia 7 and Transitions, we really use a family called indeno-fused naphthapyrans. So if you imagine this, but 2 times or 3 times bigger, that's what our current technology looks like. These molecules are similar to pharmaceuticals in terms of complexity, in terms of the number of synthetic steps it takes to manufacture them. So it's a really quite specialized chemistry. So this molecule, these are all carbon atoms in benzene or naphthalene rings. This is an oxygen, and this is the key for the photochromic activity. So when you go outdoors, UV light will start to impinge on the molecule. When you get UV light of the right energy that hits this oxygen-carbon bond, it'll actually break the bond. So this entity is colorless. When you break that bond with the UV light and you activate the molecule, it opens up. And this format, which is more planar, absorbs visible light. So this is a colored entity. And what's really clever about photochromics is when you take away the UV light, the molecule will always be moving around and it can actually reform. So that's why it goes clear indoors. One of the challenges we had in working on Transition Signature 7 is we knew from a chemistry perspective the photochromic dyes were performing a lot better. We knew in terms of the market research we were doing with consumers that consumers preferred it 2-to-1 over Transition 6, which is already the best-selling photochromic lens in the world. But if you look at the traditional ISO standard measurement systems, it's very hard to pick up that difference. So we really know that the issue was that standard system is as if you have a person wearing a lens just looking straight at the sun. And under those conditions with very high intensity UV, any photochromic lens will get reasonably dark. That's not the issue. The issue is in everyday life, if your lens is shaded or you're facing away from the sun or it's partially cloudy, you don't want the lens to be too clear. You want a certain level of darkness. So we really came up with a new measurement system which we call Life 360, which is really a way to measure under many different geographies, climates, times of day, orientation of the lens, to reproduce what a real-life wearer is doing and to use that measurement system to describe the performance of the lens. So all of our new technical literature uses that measurement system to describe the Transition Signature 7.